Good morning, students. Hope you all doing well. Myself, Selvaprakash, working as the assistant professor in Erode Sengunthar Engineering College, Chemical Engineering Department. Okay. In this video lecture, we are going to talk about the chemical reaction engineering subject, and the topic is in that subject. We are going to talk about the topic is uh, application of chemical reaction engineering. Okay. Before that, you have to know about what is the sorry before that you all know about the what is the video section, which is this has to be taken. Okay, this is for preparing higher studies for SC and ST students. The higher studies means which is GATE and JEE like that. Okay. This especially the video lecturer or the program or the video lecturer, particularly the name is Perana, which is sponsored by AICTE. Okay. Hope you all watch the slide in the basic steps. Okay, this is for AICTE Prerana program, which is specially made only for SC/ST students and for their higher education purpose. As I told previously, in this subject, in this video, we are going to see about the subject chemical reaction engineering. In this subject, the topic is application of CRE, which is how, where, or how, or else what are the steps in used in the chemical engineering field that related to the chemical reaction engineering. Okay. First question, myself, P.Selvaprakash, assistant professor working as a chemical engineering department at Erode Engineering College, Tamil Nadu. In this lecture, we are going to talk about what are the basics, some basic things about the chemical reaction engineering, and some proper definitions and a more general more balanced equation for batch reactor, or else continuous reactor, and plug flow reactor, and packed bed reactor. Uh, Now we are going to talk about what is the chemical reaction engineering, which means this is the basic subject. Okay, chemical reaction engineering is the heart of the every chemical engineering papers. Okay. Basically, how can I tell you? Generally, we all know about the chemical reaction engineering and thermodynamics or heat transfer or mass transfer. You can check the mechanical department students also study the heat transfer, mass transfer, thermodynamics paper, but not the chemical reaction engineering paper. So we can easily decide that chemical reaction engineering is the major important paper in the chemical engineering field. Industries that used the mostly chemical industries, they are using the chemical reactions and the chemical process and the chemical process design, what are the inputs are included, and how the outputs are gained. These are the basic steps they are going to study about. Okay, okay, let's begin. Theory. Theory is the field. Okay, this is like one of the mechanical engineering or civil engineering or ECE, it should be like that only. This is the one field of study that relates the rate and the mechanism of the chemical reactions and the design of the reactor in which they take place. Okay, in which they take place. Finally, you all generally you all know about the chemical reactions. For that, you have to know about what is chemical identity. Okay, how they perform in the basic industries, or else how they behave in the basic reaction kinetics in the chemical reaction engineering field. Okay, this is chemical species is said to have react when it have lost in chemical identity. The identity of chemical species is determined by the number and configuration of the species autonomous. And this is nothing but chemical identity is the simple identification process. That identification process is which is purely made up of how the configurations build or else what are the kind of atoms they have or how many number of atoms they have or what are the configurants of the atoms they have. This is okay. In chemical identification, there is the three processes here. One is decomposition, one or other one is combination, and the last one is isomerization. These are the very important three topics. Okay. In decomposition, you all know about the decomposition process. Decomposition is nothing but simply destroy, destroying the reaction to the simply known as the decomposition process. Okay. And then next is the combination. You all know about the combination word as well as the meaning of the combination. Combination. Okay, sorry, combination. As I told previously, what I previously told, decomposition is the same process that define the decomposition process of the atoms. And likewise, combination is the same process which decomposition or else isomerization or else combination. They all are same process which are clearly known about the meaning of the decomposition or isomerization or combination. These are the examples. You take a minute and watch the slide carefully. If there is any doubts, you can leave a message or comments. We will reply you. Okay. As I told you previously, decomposition is the major process, general process. What is the general process of the decomposition? Decomposition is the process by which dead organic substance are broken down into the similar organic or inorganic matters. Okay, that inorganic matters are such as carbon dioxide, water, or simple sugar, or else mineral solids. Decomposition is the one. This is the simple general process of the decomposition. Regard to combination, sorry, the next one is combination. The combination is the what is the combination general process or general meaning is nothing. The combination reaction here we can use the we can consider the reaction. So we can understand. So we can easily understand the combination reaction. Is a reaction where two or more elements or components combine to form a single component. Is the combination of reaction. Okay. The last one is isomerization. You guys already know about the isomerization in your schooling level. Isomerization reaction is nothing but this is a chemical process by which a component is transferred into any of its isomeric form. Okay, this is the isomeric form. You can watch in this slide, last left corner. Okay, isometric forms. What do you mean by isometric forms? The isometric forms is nothing some chemical combination, but with they have different structure or else configurations. Hence, generally they are different by chemically and physically. Okay. now we are going to the next slide. Rate equation or else reaction rate. Okay, the reaction rate is the rate at which a species lost or else lose its chemical identity per unit volume. Okay, the reaction rate is nothing but the simple the losses of the chemical identity at the unit volume. Okay, uh, we can simply understand the reaction rate by using the chemistry chemistry terms. In chemistry terms, the speed at which chemical reaction proceeds. This is the simple definition to understand easily. Okay, the speed at which a chemical reaction proceeds. It is often expressed by the name by the notations of concentration per unit volume of the product that formed in a unit of time or the concentration of the reactant that consumed in the unit of time. Okay. Okay. The next one is in the rate equation, the rate of reaction also expressed as either two forms. The one is the rate of disappearance of reactant or else the rate of formation. Okay. The rate of the first one is the rate of disappearance of reactant. Okay. The second one is the rate of formation. Okay. Reaction rate. Now you all know about the consider already as I told you all guys know about the isomerization process. Let's have a look about the isomerization process. Isomerization is nothing but a normal atoms or reactions or molecules converted into the isometric form. This is the isometric definition which is given by the Google. Okay. Now consider the isomerization reactions. A gives product B, RA is the rate of formation of species A per unit volume, and then the rate of formation of, or sorry, the rate of disappearance of species A per unit volume. Okay. The last one is RB. RB is the rate of formation of species B per unit volume. Okay. Now we are going to talk about the reaction rate according to the examples. Okay. Consider a simple equation A gives B. If a species B is formed at a rate of 0.2 mole per decimeter cubed per second. That is RB equal to 0.2 moles divided by decimeter cube divided by second. Then A is disappearing at the rate of minus RA equal to 0.2 moles per decimeter cube per second, and then the rate of formation, that means generation of A is RA equal to minus 0.2 moles per decimeter cube per second. This is the simple form of the question. Okay. Now we have to note about the already as I told you, the concentration. The changes in concentration according to their time is the rate of equation. Okay. Alright. Now you have to ask the question, sir, what about the catalytic reactions? How we prefer the species or the disappearance or the formation of the reactions? Okay. Now I actually explain the catalytic reactions. We refer to minus RA, which is rate of disappearance of species, and A per mass of the catalytic basis. Okay, now we are considering the species J. Okay, you guys take a minute and just read about these 4 points. I will explain the 4 points briefly within a minute. Okay, just take a look. RA is the rate of formation of species J per unit volume. mean value. And then the point two, likely you guys read about the another 3 points. I will join in a minute. Okay, are you guys completed? The second point is now listen to the second point. RJ is the function of concentration, temperature, and pressure, and the types of catalysts. If any means you all know about the catalytic reaction, that is the subtle reaction which is used by the catalyst is called the catalytic reaction. As the third point, the third point is RJ, that is reaction rate of species A is independent of the reaction type. Okay. The reaction types you already must know about this, whatever it is, like flow reactor or batch reactor, etc. Then RJ is an algebraic equation, not a differential equation. Algebraic equation. You guys already know about it. Minus RA equal to KCA. That is minus RA equal to KCA square. What is the difference between the example 1 and 2? Take a minute and have a look and tell me the difference. The main difference is okay. The main difference is example 1 is the first order reaction and example 2 is the second order reaction. Okay. This is the general mode balance for species J according to the our video lecture. This is called chapter 1 and this is named as the mode balance. Okay, building block. This is for general introduction stuff. Don't worry about it. General mode balance. Okay, take a minute and look at slide, guys. Look into the slide. Okay, what is the input on the slide? F, J, naught. And what is the output of the slide? F, J. Okay, what is the system value? You guys already know about the system value, which is a capital P, and that is converted to the system values means we already know about the this is J, and that is Cj. Okay. Okay. Now, yeah, we can come into the general mode balance equation. General mode balance equation. Take a minute and read the slide. General mode balance equation is molar flow rate of species J in minus molar flow rate of species J out and molar rate generation of species J, which all equal to the molar rate of accumulation of species J. Okay. Now we can tell this general equation in the theoretical form, but we have to denote the equation in the derivation or else mathematically. For that, mole flow rate of species J in is known as the Fj dot. Okay, you guys have to understand these equations are not come from the sky. Okay, these are taken into the our previous diagram only. Okay, molar flow rate of species J out is known as the Fj, and molar flow rate, molar flow rate generation of species J is known as the Cj, which all accumulation of the rate equation molar rate accumulation of species J is known as the final mole balance equation. Okay. Now this final mole balance equation is denoted as the dnj divided by dt. That t is denoted as the differential, so we can eliminate the t is now. You can easily remember this equation nj divided by dt. Okay. Now we are going to see about the units of this equation. First one is molar flow rate of species J in, which is denoted as the FJ, that for that one we have to the rate equation is mole divided by time, and then minus molar flow rate of species J out, which is denoted as the FJ, and that unit is mole divided by time, and then molar flow rate generation of species time J is denoted as the, according to the law, we have to know about the system volume. Okay. Before the system volumes, we all know about the uh, how the unit and the time played in the unit of the general mole balance equations. Okay. Molar rate balance of this equation is generally known about the mole and the time, which is simply denoted as the mole divided by time. Okay. Uh, okay. Take a minute and look into the slide. If there is any doubts, you can ask me. Okay. Okay. Our next slide is, for the next slide we have to know about the general types of the equations. What is the general types of the equation? We have to know about it. Okay. The general type of equation, you already know about the mole flow rate, the mole flow rate of species out, and the mole rate of generation of species Z, and the mole rate of generation of species. Okay, we have to know about this equation that is excluded from the first order, or second order, or third order reactions. Okay. So we all know about but there is a problems come under the, before that we all know about the content, what are the contents used in the slide, and then have to know about the technical terms in this slide. Okay. Molar flow rate. What is the molar mass? The, you have to know about the molar mass means in the chemistry point of view, you have to know about the definitions. Okay. In chemistry level, the molar or the chemical component is defined as the mass of the sample, mass of the sample, that compounds divided by the amount of substance in that sample. Okay. Measured in the molar mass is a bulk, not a molecular, and the property of the substance. Property of the substance is generally known about the all kind of things only. Okay. Okay. You all know about the partially uniform, the canto divided into the two terms. One is partial form and another one is non-partial form. According to the system volume, there are some fine equations to reduce the basic problems in designed by the industries. Okay. But now the general mode balance on system volume in minus out plus generation equal to accumulation. This is the theoretical form. Now you have to write about sorry. Now you have to write about the equation in mathematical form. Mathematical form we have to know about the denomination terms. So that or else we have to know about the basic input and output terms like that only. FA naught minus FA plus division on A dt divided by dNA divided by dt. This is the accumulation term. Okay. In the accumulation term, we have to know about the basic what is the input we use and what is the output we use, what is the accumulation we created in it. These are the basic steps you have to know about this video lecture. According to the building block diagrams, you all know about the basics chapter. The like the more balance, or else the more balance one, two, three diagrams. This is the mode balance equation for batch reactor. The final equation of the batch reactor mode balance equation is dNA divided by dt equal to RA. Okay. This is the diagram which is batch reactor. In the diagram, we have to know about the FA not as the FA is the output plus accumulation, that is integration or RA d dot B equal to dNA divided by dt, and then FA not under FA equal to becomes the 0, then automatically the well-mixed equation became the integration RA divided by dV equal to RE. Finally, we have to know about the calculations of the basic fundamentals, which is used in the batch reactor. Before that, we have to analyze the what are the offers given by the authority and how we use the offers according to the authorities, or else we have to know about the generally used terms. The, the next slide is batch reactor, and the final equation we got is here dNA divided by dt and equal to RE dot. Okay, according to this, dNA divided by dt equal to is simply known as the RE divided by V. The RE divided by V equal to integrating the final equation dA divided by dt and dRE divided by dt is equal to D equal to D0 and D equal to DT or else Na equal to Na naught or else Na equal to Na equal to Ne. Okay, this is the basic fundamental we used in the time necessary to reduce the number of moles of E and Na naught is directly comes from the Na naught to Ne. Okay, this is the final mole balance equation for that equation by using the final equation. We have to know about this graph value Na divided by dt equal to sorry Na divided by dt equal to area under the flow lines. Okay. Further, further we come to the next one. That one is CSTR. This is simply known as the continuous turbine tank reactor. This is the one mostly all the industries used it because this is continuous process so that we can manage the profit level by increasing by using the CSTR equations. The CSTR equations or continuous turbine tank reactors is also known as the back mix reactor or its mixed flow reactors or a continuous flow turbine tank reactor. This is the common reactor form for the chemical reaction engineering and environmental engineering. A CSTR often refers to a model used to estimate the key unit variables when using a continuous agitated tank reactor to reach a specific or specified outputs. Okay. The mathematical work, the mathematical model work for all fluids, liquids, gases, and solids is automatically given in the three type of diagrams in this slide. Looking to that, the final behavior of CSTR often approximated or modulated by that of an ideal CSTR, which assumes for perfect in a perfect mixing reactor, reagents is, reagents is spontaneously and uniformly mixed throughout the reactor upon their entry. Consequently, the output of the CSTR is a ideal limit completely mixing in reactor design, which is completely opposite of the plug flow reactor. Practice, no reactor behave ideally, but should falling somewhere in between the mixing limit of an ideal PFR and CSTR. Modeling of the reactor is the continuous stable tank reactor contains a non-consumable chemical reactants A enters into a ideal CSTR of volume B. Then we have to make some general basic assumptions for simplify the modeling process. Okay, the first one is perfect mixing and the ideal mixing. Sorry, and the second one is steady state, that is dNA divided by dt equal to 0, where Na is the number of moles of phases A. Okay. The third one is closed boundaries, constant fluid density, valid for liquids,
valid for gases and valid for solid type reactors also. Okay, the last point is our conclusion is nth order reaction where K is the reaction rate, Ca is the concentration of species, N is the order of the reaction. Okay, the next point is isothermal condition or constant temperature. Okay. Um, Before that, we have to know about the temperature basis and then ensure the constant temperature for a process. Okay. And the major and the important assumptions is the reaction is also known as simple and irreversible reaction. Okay. All reactant of A is converted into the product by using the chemical reaction. Na equal to CaW. Integral mass balance of number of moles Na of species A in a electron volume and the net of again we are into the equation. Don't confuse us. This is the explanation of the basic equations which can come the directly into the slide. Data accumulation of A equal to A in minus 0 plus net generation of A. And the next one is dNA divided by dt equal to CFA naught minus FA plus PA RE. Okay, where CFA naught is the molar flow rate let of species A and then FA is the molar flow rate output let species A. D is the Charcometric coefficient and RA is the reaction rate. Applying the assumptions of steady state and then VA equal to minus 1. Equation 2 simplifies the 0 equal to FA naught minus FA minus RE. Okay, sorry. This is the mathematical form, or else you can understand the theoretical form. The theoretical form is the molar flow rate of species A can be written in terms of the concentration and fluid flow rate. The concentration and fluid flow rate of the flux Q equal to Ca divided by C naught equal to Kn divided by number of orders used in the net. Finally, the fourth one becomes QCA naught minus QCA minus PRA. This is the fourth equation. The fourth equation becomes the 0 equal to CA naught minus CA minus PRA. Or else we can simplify by using the RA equation. RA equal to Q divided by D, CA naught minus CA. RA equal to 1 divided by D, CA naught minus CA. Where E is the resistance time and CA is the inlet concentration of species. And CA is the reactor output concentration of species. Residence time. Residence time is the total amount of quantity of reactants spent into the reactor. For an ideal reactor, the theoretical for an ideal reactor, the theoretical terms of this has been used as the according to the mole and what other molecules are used in the reactors. Okay. Finally, we have to know about the finally we have to know about the basic things or which is come from the rate, reaction, order, or concentration or time change. Majorly, we are separate the equations by using the order of the reactions, which is n equal to 0, first order reaction, sorry, 0th order reaction, n equal to 1, first order reaction, n equal bracket at n equal to third order reaction. In the residence time distribution, an ideal CSTR will define flow behavior that can be characterized by reactor's residence time distribution or the age distribution. Okay. Not all fluid particles will spend the same amount of time within the reactor, but they have to understand the terms by using the non-ideal CSTR reactor. Before that, we have to understand what are the applications are used in the environmental field by using the CSTR equations. The one is activated sludge process of wastewater treatment, and the next one is lagoon treatment. Lagoon. Sorry, lagoon treatment system for a natural wastewater treatment. And the last one is anaerobic disaster for the stabilization of wastewater biosolids. Chemical engineering. Loop reactors for pharmaceutical productions and biogas productions and fermentations. Okay. We can also see the laminar flow reactions plus microreactor or else oscillatory baffled reactors or else plug flow reactor models by using the some reference. Sorry, this is the plug flow reactor small balance equation. Polyethylene reactor is 16-inch unit reactor designed to operate 35,000 psi, that is pressure unit, and a 16-degree Fahrenheit, that is the temperature unit. In operation, this reactor is in a vertical configuration. Plug flow reactor mode balance. Fine. Briefly in this slide, plug flow reactor mode balance comes from the according to the diagram. The left hand side is equal to Fe, and the right hand side becomes the Fe naught. The general not identified or non-reactant field is called as the delta V, and the delta term is overall volume. D plus delta V equal to the total system value. Final input output accumulation is not generated or considered earlier, and this is for the steady state reactance. So the accumulation becomes the zero. Input of the chemical reactor is equal to zero. Output of the chemical reactor is equal to zero according to their accumulations. Okay. So that we have to know about the what is the feed output. Fe naught equal to Fe divided by T. And that Fe is the input and V is the volume of the system reactor before the specified volume. Okay. The next one is simply we have to know about the, in this next one the generation of the delta V is not according to the performance and profit level of the industry. Okay. The next one is finally we have to rearrange the equations. We have to rearrange the equations limits and according to the delta V equal to 0, limit equal to so Fe divided by V plus delta V minus Fe according to their V. Before that, we have to ensure there is no volume necessary to reduce the indirect mode flow rate from AAF to exit molar flow rate AF. And this is for the blood flow reactors mode balance and this, and this is for the packed bed reactor mode balance according to this, and this is the conclusion of the mode balance equations. Reactor mode balance summary.
DMDE applied to the major potent. The general considerable reaction is A gives B. Like the batch reactor, CST reactor, for reactor, and a coagulable reactor. Okay. Differential DNA divided by dt equal to RN. CSTR there is no equation. Only CSTR has the algebraic equations. That is B equal to CFA minus A divided by RN. And the last one is PFR. DFR, DFA divided by DV equal to RT. PFR equal to PFR divided by DV equal to RE dash. The last one is integral form of that equal to for batch reactor. E integral NA not equal to NE, NE divided by R REB. For BFR reactors, we have to know about the E equal to duration. EFA divided by ERA. Then last one is E equal to, this is for aggregate reactor. This is for V value. So this we can tell about the V equal to integration CNR to CA TFE divided by R. Reactors with the heat effect. Examples. These are the applications for reactors with the heating effects. Production of a polycyclic linear adiabatic CST reactor. Polypropanyl and dicyclone hydroxylate propanyl oxides are these basic important terms, and the mole balance and design equation equal with the basic form of the Fa0 minus Fa plus RAD equal to 0. The design equation in terms of X is DA equal to Ca x divided by Ra. The rate law equal to Ra equal to Kca divided by A. The stoichiometric equation in this becomes Ca0 equal to Ca0 1 minus Xa, and the combining yields V equal to Fa0 dot x K Ca0 1 minus x equal to V0 dot x divided by K into 1 minus x. Solving for an x function of t and recalling that tau equal to V divided by V0 plus xmb equal to tau k divided by 1 plus tau k equal to tau ae minus e divided by rt plus 1 plus tau ae minus e divided by rt. This equation relates the temperature under conversion of the equations to the mole balance equation. The parameter evaluation of the total heat coefficient flowing entering the gas V equal to 300 Kelvin, and if that is converted into 14.1 feet cube, and tau equal to capital V divided by small v naught, the values become the 14.01 feet cube divided by 3 326.3 feet cube divided by hours. The final answer of the tau equal to 0.123. That 0.123 is automatically used by the next step. Before then, we have to concentration. Before that, we have to calculate the concentration value of the initial. Okay. In the initial concentration, cannot the formula is Fa naught divided by Va naught equal to 43.0 pounds moles divided by hours. Secondary small V naught equal to is commonly known as the 3.26 and then 3 p cube divided by T. The one is equal to 0.132 pounds per moles per feet cube. For ethanol equal to sigma m equal to FME divided by FMB equal to 0.0182, and the final value is converted into the 9.821. According to their values, they are converted into 0.725, 8.325, and the 9.321. Uh, if we
can alternate the temperature and pressure values. We can alternate the cooling factor. If the temperature is increased to 100% in 100 degrees Celsius, the automatically the values become 12.81, 18.22, and 73.37. Okay. The last one is the simple one for water. In the water values, sigma A equal to, which is the native things. Traditionally, they are going to follow the values for using the previous sums.
Evaluate, evaluate the more balanced terms by using the conversion of called non non-reactable materials. The non-reactable materials we all know about the basic things used in the reactor, and that is the X can be equal to
2.04 into 10 into 10 to the power 2 into whole square, 9.841 and 2, sorry, 9.821 into 0.0132, then add into 14.821, then minus values for this, and then the last one is 0.27 into non-ideal and output. Follows the reactors up to may be vain, the resistance may be changed by using the 8.25. According to the 18.25, the final values of the equations to become the procedures, the general procedures for the non-ideal reactors application. Okay.
the non-ideal reactors applications are generally used in the form of the energy balance element. This is the major build for the application process based on the basic laws which is used in these reactors. Before that, I am going to explain one by one. Okay. This is the in the area application process. Separation is the major one. For the separations, we have to know about the filtration, distillation, and hydrolysis. This is about the other one. We have to know about the reaction planning. Before that, we have to all know about the mode balance and the rate law. Theory that's very important is heat effect. So what is the isochromatism and cytochromatic equation and the heat equation and finally mode balance. This is the mode balance and the rate laws for using this material. However, with the algorithm becomes the unstable. What will happen is that uh, heat equations for maintaining it becomes unstable. This means if the chocolate equation becomes the first one and the rate loss becomes the last one. Okay. Finally, the supplementary sites equation, the additional equations. So the terms which are basically used in this equations is the equation. The equations we all know about the general basic terms by using the set side value and the stand side by riser settling focus. Okay. The next application of CRE is penicillium. These are the penicillium. This is the count penicillium options, and the one is input and the another one is output. Count step liquid and the penicillin becomes the output. Okay. In this third one, the wind also may happen into the Long Beach and the Los Angeles area. In the Los Angeles area, side view of the Los Angeles area basin will change it to the representation of hills or mountains. Wind from the Majavo deserts is directly come into the Los Angeles basin, Vina, and it finally exits through the Vienna by using the chemical reactions engineering. Okay, this is the basic equations before digestion. Before digestion, this is the hippo is one of the actually we can relate it into the all our digestions. We all take inputs and dispose the outputs. Similarly, the term digestion is also mentioned here. This is the model digestion system of the human. The final even inputs like chemical engines into the quote look into the quote that they are not or told by the Matthew Robastian and Frederick Persson, Brian Bendician, Professor H. Scott Flagler. This is the other application of CRE in the hippopotamus. Before the additional applications of this wetland and wasteland, that burstland evaporation is becoming automatically addicted to the oil recovery. The oil recovery is the major point. Then only we have to acquire more tons by overtaking the some other non-useless commodities. For that only they are preferring the some related things. This is the pharmacokinetic of copra bites the multiple reactions in batch reactor combines lubricant design, nitroalkaline plant explosion, exothermic reactions that always run away. This is the simple form of this basic additions of the equation. Before that, we have to know about the before that we have to know about the automatic equation of the liquid base. V equal to V naught, C equal to C naught, and 1 minus x1 is additionally added. For that, before that, we have to know about the what are the terms basically used in the combining yield. Combining yield means nothing but we all know about the behavior of CSTR, often approximately or modeled by that of an ideal CSTR, which assumes perfect mixing. Imperfect, imperfectly mixed reactant is spontaneously mixed reactors and then reactants throughout the reactor upon entry. Consequently, the output composition is identically to compose of an inside the reactor, which is the function of residential time distribution and the reaction rate. The CSTR is an ideal limit of the completing mixing in the reactor design, which is the completely opposite to the plug flow reactors. Okay. In this big video lecture, you all know about the final conclusion stage. Okay, this is one of the major important parts. Now you guys easily listen about this. In this video lecture, I am covered at my best level introduction, definitions, and general mode balance equations, a batch reactor and continuous stirred tank reactor, plug flow reactor, and packed batch reactor. In the chemical reactor engineering paper is the one of the major and important paper of the chemical engineering field, or else you can relate it with the mechanical and civil and automobiles and anything else.
they are going to start. They are not going to study about the chemical reactions. They will may study the mass transfer, heat transfer, and thermodynamics. This is the general terms which is used in reactants by using the non-identical terms, but in that distance they will taking the place. But actually, in this field, we have to know about the time species and chemical identity. But chemical identity is majorly defined as this decomposition, combination, and isomerization. Reaction rate is the rate which combined among this. This is the basic isomerization equations, and this is the example for A and B given equations. So basically, by using this, the actually the time will come. And so we have to conclude it so fastly. If there is any doubts, leave a message or leave a text. For catalytic reactions, we perform minus RA, which is the rate of the disappearance or species of A as per the mass of catalytic basis. Generally, generally this is the batch reactor to use the mole balance. FAR minus FA plus RA divided by KT and then RE divided by GT dot equal to integration by using in terms, but by using the RA dot dV dt equal to D. DNA divided by dt equal to same formula for all equations. Here we are going to study about some basic related things. Or we are going to using these terms by using the norm, acts, or else items. Packet bed reactor, this is the packet bed reactor. Finally, the conclusion of the this one by using some time. But according to the heat effects, there is some changes will happen. That will happen in the process. These are the some basic equations which comes from the equations. Okay. By using these terms are many major important terms by using the CRE or else the chemical reactions engineering subject is one of the chemical basis papers for all chemical engineers. If there is, if you have any interest in it, you have to search in the web culture websites or else textbooks. All of you refer the today video lecture. And thank you guys. Thank you so much.